Good morning, everybody. We are going to do a couple sections here from Chapter 9 to wrap up our week before spring break. So initially I was just going to do Section 9.3, but then I realized just how short Section 9.3 is. So we're going to do 9.3 and 9.4. So the distributions that we're going to use for hypothesis testing are going to be these: the normal distribution and the student t. Just like when we did confidence intervals, we're going to use the normal under certain circumstances. We're going to use the student t under one particular circumstance. So if we're testing a mean and we know the population standard deviation, which again, that's a little bit of an unlikely scenario, but if that's what we've got, okay, we're testing a mean, we know the standard deviation, that's sigma, then we use the normal distribution. So in our calculators, when we get to that point, we'll be using the z-test. If we're testing a mean and we don't know the population standard deviation, so we don't have sigma, then we use the student t. So in that case, in our calculator, we'd be using the t-test. And finally, if we're testing a proportion, we're going to use the normal distribution again. This one will be 1 prop z-test when we get to that point in the calculator. That is all for Section 9.3, which is why we're moving on to Section 9.4. But before we do, there is one thing I should point out. This all implies or assumes that we're dealing with single means or proportions. Later on, if we get to it, which I think we will, but if later on we get to Chapter 10, we'll talk about comparing two means or comparing two proportions in two different populations. So none of that is happening yet, though. All of this assumes that we're dealing with single values. All right, Section 9.4 talks about how we make our decision to reject or fail to reject the null hypothesis. So we begin with a discussion of the rare event rule. And in the rare event rule, we've said this before, if you have a given assumption and you observe an event that is very unlikely under that assumption, then we assume that the assumption must be incorrect. Okay, remember that the assumption is something that we are assuming. It is not something that we know to be true. So we have a particular assumption, and then we go to the real world and we collect some data, and if the probability of getting the data that we got was very low, then we don't assume that our data is bad, we assume that our assumption was bad. All right, so that's the idea for using a sample to test a hypothesis. So what we're going to do is we're going to use the sample data to calculate something called the p-value. P in this case just stands for probability. Okay, it's probability value. Although we kind of call it p-value as a special name for this particular probability. To give you just a little more technical definition, if you want it, the p-value is the probability that if the null hypothesis is true, that we would get results that are as extreme or more extreme than the results that we got. So again, we have an assumption about our population. Okay, that assumption is that the null hypothesis is true. So we test it using the sample data, and if the probability of getting our sample data is really low, well, then that's going to tell us something about the null hypothesis. So specifically, what we will compare the p-value to is something called the significance level, which is just the name for alpha. Okay, we talked about alpha in Chapter 8, and we calculated alpha by finding 1 minus the confidence level. Okay, so with hypothesis testing, we don't speak in terms of confidence level anymore. We speak in terms of significance level. But significance level and confidence level are still tied together. Alpha and the confidence level have the same relationship that they did in Chapter 8. So the p-value will be compared to alpha. Alpha is typically something like 0.05 or 0.01, something like that. It'll vary some from problem to problem. Okay, specifically, if p is less than alpha, then we reject the null hypothesis. If p is greater than or equal to alpha, then we either fail to reject the null or we do not reject the null. I forget what well, there was one other phrasing that our textbook uses. Not neglect. I don't know, I can't remember. But anyway, we're not going to reject the null if the p is greater than or equal to alpha. So eventually you will get to a point where you will be staring at a quiz or a test or something, and you'll be like, I can't remember was it the p less than alpha or p greater than alpha. So here's kind of a silly way to remember it. Okay, if the p-value is low, the null must go, which means we would reject the null. If the p-value is high, the null will fly. In this case, will fly means like it'll work. So we would not reject it in that case. So just kind of a silly way to remember, when to reject, when not to reject. All right, so let's look at an example of how we would approach some problems here in section 4. Here we have a baker who has he's made a claim that the bread height from his bakery is more than 15 centimeters on average. So apparently he has skeptical customers. So to persuade them, he bakes 10 loaves of bread. He finds that the mean height of these loaves is 17 centimeters. And we're assuming that he knows the standard deviation of his bread height as 0.5 centimeters with a normal distribution. So this is kind of a silly example, but nevertheless it gives us an idea. So first we want to identify our null and alternative hypotheses. So remember that the way we did this in, I think it was section 1, is we said the claim and then the opposite of the claim. So in this case, the claim is the height of his bread is more than or greater than 15 centimeters. Okay, the opposite of that would be that his bread is less than or equal to 15 centimeters. Okay, so that means that the null will be the less than or equal to 15, because remember the null always contains equality, and the alternative will be that the bread height is greater than 15 centimeters. So in this case we can use mu. Let's say that mu is less than or equal to 15 centimeters, that's our null. Mu is greater than 15 centimeters, that's our alternative. All right, so which distribution should we use? Well, we're dealing with a mean, and we know the standard deviation, right? We're told that the standard deviation is 0.5 centimeters. So, and we know that the distribution is supposed to be normal. So all of that adds up to, we're going to use the normal distribution. We're going to use z. All right, so skipping the actual math to find the p-value, because we're not quite there yet, let's just assume I found the p-value for you and it's very, very close to 0. Okay, it's a very, very small number. So what would we do? Well, we're not given a specific alpha here, but if the p-value is basically 0, then whatever alpha is, p-value is going to be less than that, right? So the p is low, so the null must go. So we reject the null hypothesis. All right, so the important thing though is not just to get to reject the null hypothesis. That's fine. That's the correct conclusion, or I should say the correct decision. But the actual conclusion is, what do we know now about the baker's bread height? Okay, what does that tell us? Well, remember that his claim is greater than, right, which was our alternative hypothesis. So in this case, if we're saying we reject the null hypothesis, then the data therefore supports the alternative hypothesis. And the alternative hypothesis is that the bread height is greater than 15 centimeters. So our final answer here, final conclusion would be the sample data suggests that the baker's claim is, well, let me say it this way. The baker's claim that his bread height is more than 15 centimeters is supported by the data. That would be a good way to say it. We haven't proven that he's correct, but we have found data that supports his claim. Okay, for example number 2, little less wordy than the last one, so hopefully this is, if you're getting kind of lost in all the words, hopefully this one will be better. It's a Boy Genetics Labs claims that their procedures improve the chances of a boy being born. So they test They run a sample, they get some test data. If their procedure doesn't work, then we're assuming that the chances of having a boy versus having a girl is 0.5. Okay, what they're claiming is that they improve the chances, so their p-value, or excuse me, their proportion would be greater than 0.5. Okay, in this case, the p that you see there is not a p-value. That p is the population proportion. Okay, if the null hypothesis is that the proportion is 0.5, the alternative is that they have improved that and the proportion is greater than 0.5. So we're testing with an alpha with a significance level of 0.01, and through taking a sample and running the math, we get a p-value of 0.025. All right, so interpret the results and state a conclusion in simple, non-technical terms. So I'm going to let you do this as a kind of a pre-homework problem. What I'd like you to do is I would like you to interpret the result, state your conclusion in a post on Google Classroom. Okay, leave it as a comment on. I'll put an example number 2 announcement maybe on Google Classroom, and you guys can leave comments there. So even if somebody's already answered it before you get there, maybe your wording is a little different or whatever. So go ahead and put what you get in there, and we'll see how people, maybe how people differ and how they state things. All right, so your homework in this section is number 21, which is from section 3, and then 32 to 36, which is from section 4. So section 3 is pretty short. I didn't think there was a lot of homework questions in there that were really worthwhile, so I picked just the kind of the simplest one. All right, so good luck on this. I hope you guys have a chance to finish this up before spring break, and hope that you have a great spring break. And unfortunately, it doesn't look like I'm going to see you in person when we get back, but I look forward to continuing and seeing you guys in the Google Meets and the Zoom meetings and whatnot. So just know that I'm praying for you guys, and I miss you guys, and hope you're doing well.